Alright, hello there gang. So we've got our next lesson on tap today. It is section 1.5, Parent Functions and Transformations. This educational experience is brought to you by your Sultan of Shifting, Mr. Faust. Now, shifting, what's that going to be talking about? Well, we'll get there in a little bit. But first, let's talk about some of our parent functions. Okay, the first function on the tap today is a constant function. Why is it called a constant function? Because it's a straight across line there. Alright, we have some things to talk about. The domain is all real numbers. There's no problem with x here whatsoever. So negative infinity to infinity for my domain. My range, however, is a little bit different. My range for these functions is whatever c is. Now, why do you say that? Because literally, my y value is just straight across here at c, so it's only going to be my c value. And it's not increasing or decreasing. It's constant. So that's something very important for us. Alright, let's go on to our next one. Our next function we have to talk about here is our identity function. Generally speaking, it's y equals x, or f of x equals x. So we need to talk about domain. Domain here again is all real numbers. I've got no issues with my domain putting in any x value I want. And what's great now for my range is I also have negative infinity to infinity, because as you see, this graph goes in either direction. For example, being like y equals 2x. That's an identity function. Now, an example being here for my increasing or decreasing, well, it depends on what your slope is. Positive slope means increasing, negative slope means decreasing. Okay, next we have a good old quadratic function. You've all seen this before. Now, a quadratic function, again, has a domain of negative infinity to infinity. You see the pattern here a little bit. That means no x I can pick is going to cause me a problem right now. We're all good. My range, however, my range for this problem is going to be, I can include 0, but I'm going to go to infinity because there's no way I can square something and get a negative. So for my basic quadratic, I have the range from 0 to infinity. Now, if this quadratic moves up or down, that will change my range a little bit, which we will talk about that later. Now, this thing is decreasing from negative infinity all the way down to 0, and it's increasing from 0 to infinity. Now, that's all well and good. If I move this thing to the left or to the right, that will change where it's increasing or decreasing. But we will also talk about that later. Now, the next function we have on tap is a cubic function. Now, a cubic function, again, domain, nothing new here, negative infinity to infinity. That seems like it's a bit of a pattern, and it is. My range also is going to be negative infinity to infinity. It's also increasing everywhere here. As I go along this thing from left to right, it's increasing everywhere. So that's very important for us. It's increasing from negative infinity to infinity. Now, if I threw a negative out in front, it would obviously flip things around, but we'll talk about that in a little bit. Next parent function we have to talk about here is a square root function. Now, here is the first time all day long I've got a slight bit of problem with domain. Because as you recall, what I'm not allowed to have is the square root of a negative number. So, my domain goes from 0 to infinity. I can include 0 because I can take the square root of 0. Note how my graph here has no negative x's. It starts right there and slowly goes along. Conversely, my range is also from 0 to infinity. Because I could have 0, but there's no way I can get a negative y value because there's no way this square root here can produce a negative number. And it's increasing all the way along here from 0 to infinity. Now, it might not be increasing that quickly, but it's still increasing, so it still counts. Okay, now the next one is what we call a reciprocal function. Why is it called that? Because, well, it's literally the reciprocal of y equals x. So we've got some issues here. Domain, I've only really got one problem here. In my domain, obviously I can't divide by 0. So I can go from negative infinity to 0, and I'll go with the union, the u in the middle there, of these two sets. Now, why in the world do I have this? Well, if you notice, there's no closed brackets here, so I'm not including 0. Now, my range, I can be anything I want, except what? I'm never going to be able to hit 0 here, am I? So my range goes from negative infinity to 0, union 0 to infinity. If there's an asymptote here, which there is, right along there, I'm never going to be able to get to 0. I will get what we call asymptotically close, or really close to an asymptote, but I'm never actually going to be able to hit 0, so we're okay. Now it's decreasing from negative infinity all the way down. Look, it's decreasing everywhere. As I move from left to right, it's always going to be decreasing. This thing is never increasing, so it's decreasing everywhere. It might seem like it's increasing over here, but moving from left to right, look how it's going down. So it's decreasing everywhere there. Now, the next one that you see is called an absolute value, which you've obviously seen this before. Now, absolute value, domain, I could be whatever I want to be. I could put any x in, I'm not going to have a problem with it. It's going to be okay in my function. However, my range, an absolute value, if you recall, is always positive. So I could have 0, but I'm going to go to infinity from there, because I can't have a negative. I can't make this be negative. You look at the graph there doesn't go below 0. Now, if I shift, when we shift shortly, shift these graphs down, that will affect my range. So it's something important we have to look at there. Now, the next function is probably something you haven't seen before. It's called the greatest integer parent function. It's denoted with double brackets around it. So it looks like this. It's also called a step function. Why do we call it a step function? Because we are literally going to be stepping up every time. So the greatest integer is just saying that, hey, I want to find the next biggest integer. So we move up. So here the biggest integer is like 2. From 2 there, my integer is 1. And then I move up to the next integer. Then to the next integer. You're just moving up to whole numbers. That's all it is. It creates a step effect, so to speak. So if I ask you what happens at x equals 3, I go to my biggest integer, 3. And from 3 to 4, I still am at 3 there. So you look at your integers. It's one of the more confusing ones if you think about it, but it's not so bad if you think I'm just creating steps. I'm not doing anything different other than creating a steps at the given integer. Okay, so now that we have our parent functions down, let's talk about some transformations. The first transformation is what we like to call in the business a vertical shift up c units, denoted by some f of x plus c. An example, I'm going to stick with x squared here, just because it's the prettiest one to graph. So, x squared plus 2. This plus 2 is my vertical shift. Now, what that's going to do is it's going to take my usual cute x squared, which was in black here, and it's going to shift it up 2 whole units. Every y value gets 2 added to it. Oh, happy days are here again. So just 1, 2, and up it grows. Now, what's that going to do to my function? Does it change my domain? No. It was negative infinity to infinity. It doesn't change my domain. Will it change my range? Yes. Why is that? Because I added 2 to it I should then add 2 to my range. It doesn't affect infinity, obviously, but now my range goes to 2 to infinity. Because it was at 0 here, now that I added 2, the lowest point this graph could get to is 2. That's why my range starts at 2 there. The next transformation I have is one of the following. A vertical shift down c units, f of x minus c. An example being x squared minus 2. Now this minus 2 is going to take what used to be a nice pretty graph and shift it down 2 units. Now, what does that do to my graph? Well, it doesn't change my domain again, because my domain was negative infinity to infinity. However, my range, which was from 0 to infinity, now is from negative 2 to infinity. Now, I know what you're going to say, Mr. Faust, I can't square a number and get a negative. You're right, you can't. So the lowest this could be is 0. Right here is 0, but then I'm taking 2 away from it. So I can get negatives now because I put a 1 in here. Square 1, you get 1. 1 minus 2, negative 1. So I can get negatives. Here is one of the most confusing transformations for you to comprehend. One of the two. It's a horizontal shift right c units. Now I know what you're going to say. Let's just get out of my way here. But wait a minute. How in the world am I going to the right when I'm subtracting? Well, it's going to look like this. Now you could do this with a t-chart if you wanted to prove your point. But essentially I'm taking my graph and sliding it over to the right 2 units with that negative. Like this. Now, what does that do to my range? Nothing, right? I didn't move up or down. Domain, it doesn't matter because it was negative infinity to infinity. So, shifting it either direction, left or right, doesn't make a darn bit of difference for my domain for x squared. It will for other functions, like our square roots. Now, I have a horizontal shift left c units. What is that going to look like for me? Well, it looks like this, where you have a plus on the inside. And that's going to take my graph and move it over 2 units to the left. Now, what we have to remember here is the following fact. Whatever is on the inside of my expression, whether it be a cube out here or a square root, you do the opposite. So if it says plus, you're really going to go left. If it says minus, you're really going to go right. So the trick is what we like to call opposite on the inside. That's a little trick you can use. So opposite on the inside. Now we have a few more transformations to go. Now from here, we have a reflection about the x-axis. You put a negative out in front of the whole function. Y equals negative x squared. What's it going to do? It's going to take my graph and make it do a handstand. Like that. Now I know what you're saying, but you're squaring numbers. You're right. But this negative out here is not affected by that exponent. So, we don't have to worry about that. Now, what does this do to my domain? Nothing. What does this do to my range? Well, guess what happens now? Because I flip it around, I get to flip this thing around. So I go from negative infinity all the way up to 0. See how before we used to have 0 to infinity? I flip them around, and then I simply flip the sign. Flip the sign to 0 makes no difference. And the last transformation we have to cover is the following. We are going to cover reflection about the y-axis. What the heck does that mean? That means instead of making the whole function negative, you make just the inside negative. Now, why did I do that with x squared of x? Simple. Because doing it with a x squared doesn't matter. Like that. So you have my old domain and my new domain, and the